in this unit number 2, is the radiating elements and arrays. Okay, which are the elements are useful for the radiating purpose and how array is formed by using n number of elements of antennas, right? This is in this unit number 2 we are going to study. Now this unit number 2 is totally analytical and number of derivations are there for this. Okay, suppose analytical treatment of these elements, that means types of antenna and analytical treatment, how E field, H field, resistance is calculated at this side. Okay, and the comparison of this. And the next point is types of arrays: 2-element array, n-element array, uniform arrays, broadside array, end fire array. Okay, and in this unit also planar, log periodic and Yagi-Uda antenna. This is the syllabus for this unit number 2. Okay, again the reference book for the antenna. Now only these first 2 units are based on the antenna. Okay, and the remaining 4 units are on microwave communication, right? That is the microwave part. Now for the first 2 units, you can refer these 2 books, C.A. Balani and the K.D. Prasad. Okay, now we will first complete the basics of array, or just suppose now again this Maxwell's equation. Everywhere we are going to use this Maxwell's equation because the basic communications start with this Maxwell communication, right? So whatever the electromagnetic waves, it is a combination of E field and the H field, that is your Maxwell equations, right? Now in phasor form, because in this phasor form we are considering the wave, air as a medium. So in that you have to consider the phasor form, that is the e raised to, that is important for the angle purpose. Okay, now here whatever the dabba by dabba t is replaced by j omega. Generally del cross h bar is equal to minus dabba by dabba minus dabba e square by dabba t. याद है, उसको हमने फेजर में कन्वर्ट किया है. So वो sigma plus j omega epsilon. These are the basic Maxwell's equation in phasor form. So please note down this. Give the heading for unit number 2 also, radiating elements and arrays. And please note down this Maxwell's equation in phasor form. Done with this?
Yes, ma'am.
Okay. Now we will go through first antennas. Right? Now, listen students, whatever the requirement, that means first basic antenna is your wire antenna. In many applications, there is a requirement to minimize the complexity of the antenna and the geometry to keep the mathematical analysis to minimum. As the structure is complicated for the antenna, whatever the analytical analysis is difficult. Okay, so the most versatile, oldest and simplest antenna is your wire antenna. Simple one wire making the shape of dipole, or you are giving the shape of that wire antenna as a circular loop, right? Square shape is also there. Okay, so the antennas in the form of the straight wire are called as the linear wire antennas, right? That is a simple wire antenna. Now suppose in this case See, this is the one, two transmission lines or two wires are there in this case. First one is the positive and second one is the negative. Now how the electric field, these two arrows are showing the distribution of electric field when the current is there. Magnetic field is also there, right? And we have given one tapered structure to this wires or transmission lines. ठीक है ये तो यहाँ पे field देखो ये जो दो arrow यहाँ these two arrows are visible simple from positive to negative. So when we give the tapered structure this arrow, that means fields are like this. Okay, again we have given the shape of this simple two poles, that is the dipoles, positive and negative. So positive and negative, whatever this dotted arrow shows the electric field, right? How that field is detaching from this antenna in the far field. Okay, so this length, whatever the length from this plus to this minus, this is your length of the antenna. Okay, and generally it is in the wavelength lambda. Okay, now here it is shown as the 2L, evolution of the dipole of total length 2L and the diameter D. Okay, so this is the diameter D of the antenna and this is the antenna 2L. Now this is the 2L is the length shown in this figure, but whatever the fixed length of the antennas, now as per the wire antennas, there is a, suppose we have taken the small length of the wire and that is the very small, so the name is infinitesimal dipole. So length is less than or equal to lambda by 50. Whatever the wavelength is coming according to the frequency, at which frequency you are operating your antenna, lambda is equal to C by F. That lambda is coming. Depend on that lambda, your length is decided. Okay, so the infinitesimal dipole, your length is less than equal to lambda by 50. That means it is too small. Then lambda by 50 to lambda by 10. That length is small dipole. Then lambda by 2 to lambda, that is your finite length antenna. Okay, dipole antenna. And next one is when your length is equal to lambda by 2. Correctly lambda by 2. So it is known as half wavelength dipole antenna. Half wave dipole antenna. Okay, that is the half wavelength. Wavelength ka half, that is the half wavelength antenna, right? Also known as half wave dipole antenna. Okay, these are the fixed lanes for the dipole antennas, depends on the wavelength. Please note down important topic, wire antennas, which types of wire antennas are there, and it depends, name is depends on the length. Okay, done?
Yes.
Okay. Please draw this diagram also, dipole antenna, how the length of the antenna is formed. And also the main is the current distribution along this Length of the antenna depends on the length of the wire. Okay, this length of the antenna, current distribution along this, जो भी यहाँ पे current distribution दिख रहा है like a sine wave, that is depends on the length of the wire. That means the length of the antenna. Done?
Yes, ma'am.
Okay. Now, whatever the wire antennas, we have seen these four types of antennas: infinitesimal, small, finite, and half wave dipole. Okay. For this wire antennas, there is a analytical treatment of this antenna. That means for this determination of radiating field. Now in this unit, this four dipole analysis is there. So for that, what is the define the source? Write expression for retarded vector potential A bar. Okay, whatever the electromagnetics term, completely Maxwell's equation A, V, we are going to use in this case. Determine the retarded vector potential. Convert A bar to spherical coordinate system. Determine H bar. Determine E bar. Determine E bar cross H bar. Then we will get the power. And that from power again, E is equal to I square R. From that power, we will calculate the radiation resistance. This number of parameters we are going to derive. Okay, so this is the completely 8-10 mark question, right? So to derive all this, now this is 3 to 4 page derivation complete. Okay, so in next lecture we will complete this because I don't have that derivation scan notes. Now we will start with this antennas array. Okay, so now antenna arrays, as the name is
Hello.
there. Yes.